Hi everyone. The question says a particle moves along the x-axis. According to the equation, x equals 2.04 plus 3.06t minus 1t squared, where x is in meters and t is in seconds. Find the position, part A, of the particle at t equals 2.80 seconds. Write down the given information. We are given the position as a function of time. We are given the position as a function of time. Good. Part A is asking you again, find the position at t equals to 2.80 seconds. So, x of t equals 2.80 seconds, that's what you're looking for. Write down the equation. Every time you get to t, you plug in the time that is given to you, right? For your variable, you plug in the time, t equals 2.80 seconds, and you will have 2.77 meters, check. Moving on to part B, finding the velocity at 2.80 seconds. What is the velocity? If the equation for position is given to you, to get to velocity, you differentiate the position with respect to time. d dt of the position equation. Following me? Good. Now, how do you differentiate? This is the time you should pay attention if you forgot calculus. The derivative of a constant. Derivative means how fast this is changing, right? A constant does not change, so the derivative of a constant is going to be 0. The derivative of 3.06t, t has a power of 1. How do you work with the exponents? The exponent comes down as the coefficient. Then you have to subtract 1 from the exponent. 1 minus 1 is 0. Anything raised to the 0 power is 1. So this term is going to leave you out 3.06. Here you have nothing. And finally, we have negative 1, t raised to the second power. What's going to happen? The 2 is going to come down, 2. And the exponent 2 minus 1 will give you 1. So what am I getting from the third term? I'm getting negative 2.00 followed by t. So which is why you will go to the next line. See here the velocity equation. Once you find the velocity, you don't just stop there. Now you have to plug in t equal to 2.80 seconds, which I did in the next line, and I end up having negative 2.54 meters. Check. Finally, the acceleration at the same time. How do you find the acceleration? Acceleration is the derivative of velocity with respect to time, d dt of v. Again, what's the derivative of a constant? Nothing, 0. What's the derivative of negative 2t? T has a power of 1. 1 is going to come down as the coefficient. Time minus 1 is going to give you 0. Anything t raised to the 0 is going to give you 1. So you just have negative 2 coming. You don't have any more t's. You don't have any more variables left. What does that mean? For all times, regardless of what you plug in, t equal to 0 seconds, 1 second, 2 seconds, whatever you plug in, there's nothing to plug in, so your acceleration is constant. That's it for this problem.